Hey and welcome back. In the previous video, we have learned how to set up the signaling between two clients or sending start call and receiving accept call. But this time, actually, we are going to learn how to start the local stream or how to open our camera and start the video track and make it ready to transfer. To do that, let's start from on surface local ready inside our main screen. We want to create this function inside our main view model, like that. And then we should have a class named WebRTC factory and call prepare local stream and give local renderer to it. So let's create this class. I'll go inside my WebRTC package and create a new class named WebRTC factory. First, we want to make it singleton because we only want one instance from this class. And then it's going to be injectable and has the constructor. And inside the constructor, we will have the application of type application and JSON. So let's go ahead inside our main view model and add this class inside our main view model's constructor, WebRTC factory. And then down here, let's create this member function inside our WebRTC factory. Actually, to prepare the local stream, it means to open the camera and preview the view track inside SurfaceViewRenderer, we have to do something. For example, initializing the PeerConnection factory and then create it. So we need a way to initialize our PeerConnection factory. To do that, I'll create a private function and name it init PeerConnection factory, which will get a context of type context. So we will create an option using PeerConnection factory that initialization options. And then inside the constructor, we use the builder class and pass the context to it. And now it's time to set some variables to it. So we will set enable internal tracer to true, set field trials to this string. We should use lowercase builder and also create initialization options. Now it's time to use PeerConnection factory and pass the options to initialize function. With this way, we will initialize our PeerConnection factory. But we need to make sure everything happens once this class is created. So using init block, we want to call init PeerConnection factory and pass the application as the context to it. Now it's time to have a function that will create the PeerConnection factory actually. So we will write PeerConnection factory. It will return the PeerConnection factory. So let's simply return PeerConnection factory dot builder and set video decoder factory to default. Video decoder factory, as you can see, it requires an EGL based context. So let's create this context up here. Private val EGL base context is equal EGL base dot create and get the EGL based context here. So let's pass it here. Now let's set video encoder factory also to default video encoder factory. As you can see, it requires the EGL based context again. So we will pass the same EGL based context. It asks if we want to enable VP8 encoder. We simply pass true. And for the H.265 high profile, we also pass true to it. Now let's set some options to it, which will be PeerConnection factory options that we apply some block on it that disable encryption to false and disable network monitor also to false. And in the end, we want to create the PeerConnection factory. So with this way, we know a way how to create the PeerConnection factory. But up here, we want to create a way to actually create our PeerConnection factory. So we are going to set up our PeerConnection factory lazily, like this. PeerConnection factory by lazy. And we know how to create it, so we simply pass create PeerConnection factory. With this way, whenever we use this variable, this function, and create these PeerConnection factory objects. Now that we have this PeerConnection factory, which is in charge for everything, we can have our function to prepare the local stream. We need to first initialize our SurfaceViewRenderer. It means that we should, set up the SurfaceViewRenderer to be ready to preview the video track. We need to write a function fun init surface view. It's going to get a view renderer of type SurfaceViewRenderer. All it does, we wanna set mirror to false. You can set it to true, which will work as the front camera. Let's make it true. We wanna enable hardware scaler to true, and then use the init function, pass EGL based context, and for the renderer events, we don't want any callback, so we simply pass null to it. So first thing is to init surface view, pass the local renderer. Now it's time to use this start local video and pass the local renderer to it. And this function is in charge to set up the local stream actually. So let's have the start local stream video. Let's name it surface. So inside this one, we first have to create our surface texture helper, which is going to be a surface texture helper.create. Let's import this one. For the thread name, we want to use current thread name. And for the context, we simply pass the EGL based context. Now we are going to need the video capturer. Actually, video capturer is the class that makes the camera open and start the camera. So it's from the camera 2 class within the Android itself. So let's go ahead and create this video capturer. Up here, we wanna create a video capturer, which is going to be of type camera video capturer, and it's going to be null initially. Now let's create a function that sets up this video capture. Down here, we will have a private fun get video capture that returns the camera video capture. We want to return the camera to enumerator and pass the application to it and use a run block on it. So we want to use the device name and find the one who is front facing. And if it's not null, we simply want to create capturer. And for the handler, we simply pass null to it. But if it doesn't, we want to throw the exception, illegal state exception. So let's go up here and use the video capture to get video capture and initialize it. We use the video capture and use the initialize function. As you can see, it requires a surface texture helper, which we already created. And for the context, we give the context of the surface. And for the capture observer, we need to create a video source and use its capture observer. Let's go up here and create this one. I'm gonna create my video source, local video source, lazily again, using PeerConnection factory, create video source. And for his screencast, we simply want to pass false. I'm going to create my audio source like this and pass the empty media constraint to it. So we have both of them. Let's go back down here and use local video source and get the capture observer. Now start the capturing with the dimension and FPS that we want. I use 420, 480 and 10 FPS. Now the camera is opened. We want to create our video track and audio track. So using local video track that we don't have yet, let's go up here again. We want to create a private var local video track of type video track and make it null initially. Let's move it up here. And also same for local audio track of type audio track, and it's going to be null initially. Now let's go ahead and instantiate both of them here. So local video track is going to be a PeerConnection factory, creates video track, and for the stream ID, let's create a unique identifier here. Private val stream ID. It's going to be a simple string using simple call application and get our user ID, and we add a tag with stream like this. So we pass the stream ID to it, and for video source we use local video source. Also, since it's the video, we want to add underline video to it. Right here we can use video track that is prepared and add the preview to the surface. Now it's time to create our local audio track. As it suggests, we can use the PeerConnection factory and concat the audio tag to it and use the audio source. Now that we have both tracks, it's time to create our local stream. So let's go up here again, private var local stream. It's going to be a type of media stream from WebRTC class and null initially, of course. Let's go ahead and create this one also. Local stream is going to be created by PeerConnection factory class. Create local stream, and here is the tag. Now the last thing is to add both of tracks, video track and local audio track. So our local stream is ready whenever we call this prepare local stream function, and it's going to be ready to add it to our PeerConnection factory and start a call. With this way we will create our local stream. Now there are some functions that we want to add here. The first one is on destroy. So whenever we use on destroy on this class, we wanna destroy the video capture and release the audio track and video track. So let's start with video capture and stop capture, and then dispose it. And after that, use the local audio track. You should check if it's not null. Let's enable it, or let's disable it actually, and dispose it. After that, it's time for local video track and dispose, of course, and local stream. And there are some helper functions to switch the camera like this. We use video capture and simply switch camera without any callback. We simply pass null to it, and toggle mic. We check the enabled flag of type boolean. We want to use the local audio track and set enabled to enabled. Same goes for toggle camera. We want to have the enabled flag also. So we use local video track to set enabled to enabled. on this step, we are good to start previewing the local stream, but later we will have a function to create the RTC clients. Function 2. So we can test it actually. Let's go ahead inside our view model. Yeah, we are preparing the local stream using the WebRTC. We should be able to run this application right now. So here are my two emulators. If I copy this one and paste it here, let's press car. You can see this one started the local stream successfully. And if we press yes here, this one is also started the local stream successfully. So that's it for this video. Let's move to the next video that we actually start signaling and create a video call. So see the next video. See ya.